out a way to post me showing how to do metric conversions. So my original idea was, look, I'll go to my phone and I'll record that using my phone. And this, I mean, believe me, this is going to reveal my ignorance, okay? But that's okay. I went to my phone and I started recording a little mini lecture on metric conversions, which is something we're going to talk about today. And I recorded a tiny bit because I didn't want to, it was like an experiment. But I thought, okay, I'll just record myself drawing and stuff. And that was fine. It recorded it. But then I couldn't figure out how to access it. I tried to send it to them as an email so then I could, you know, open it up here and use it as part of the class. And none of my email services would let me do that because they said it was too big of a file. So I finally just gave up on that. I mean, that seemed like a great idea to me. Now, you know, a great idea to somebody who's probably not technologically sophisticated enough. Oh, I know I could probably record it on here like this, but I was actually shooting at a whiteboard and thinking I'll shoot off this whiteboard and then I'll do this, and it didn't work. So I've tried a different strategy. And that meant that I altered the metric system PowerPoint that I'm going to work on today. And I've reposted the brand new metric system PowerPoint, just so you know. Okay. So anyway, I appreciate that everybody's here. I am excited to get ready to go to class. And like I said, I'm going to kind of crunch class today because I have to stop class pretty close to 3:45 in order to get that appointment. But at that point in time, you are going to switch to the metric measuring lab and you're going to start working through it. There's quite a bit of interactive stuff on that lab. And so you will need to complete some assignments, take some pictures, send those pictures to me so that I can see that you've completed the assignment. And I got to admit it, we're playing with a brand new lab that never existed before that's designed for the virtual workspace. And so if we discover there's big problems with it, we'll work those problems through. I'm going to show you that lab today. Okay, so I'm getting a little bit ahead of myself. So let me instead jump down here to this. Okay, and this is something that I expect to display every day. It's our little agenda for the day. Okay, and let me just double check to make sure I'm recording and I'm presenting. So I'm assuming everybody can see this. Mm-hmm. This is so this is our way too big agenda for today. All right, and every day that we meet, I'm going to have one of these so that you can take notes off of it. I mean, look, I'm not going to post this particular little PowerPoint. I'm just going to show it to you, and then you can look at it. And if there's anything that you want to write down from it, you can. Okay. Now, again, I know there are people here today who were not here yesterday, and so. You know, I mean, we're into it. We're jumping into summer school. There's a ton of material that needs to be covered. I would be happy to answer questions. I've even set it up so that I've got it right here where I want to ask if there's questions about the syllabus and the schedule. Okay. But let me mention this right here. I'm going to jump right down to the bottom here, which says, Bio156IN, Lecture 1, July 1, SSB2020. That stands for Summer Session B 2020. You can see I've uploaded the entire 3 hours and 45 minutes of lecture. Hey, it even has recorded the breaks, right? I didn't even pause it for the darn breaks. And so it's 3 hours and 45 minutes, and feel free to zoom through any part of it that you want to. But here it is. There's the link on YouTube. It should take you directly to that video. And that way, should you, I don't know, you can watch this again to get all the content, or you could watch this in the middle of the night if you need to fall asleep and you're have insomnia or something. But there's the lecture from yesterday, and I will let you know about other links. Now, if you go to YouTube under Stephen Mackey Bio156, you're going to see a lot of lectures there. So be sure you're looking at this particular one, Lecture 1, July 1. It's probably the number one up there. It's probably the first one that's posted. Okay, but then let's go back to the top of the agenda here. And again, I'm kind of excited. This is typical for me. I'm excited. I want to get started. I want to say again, though, how happy I am that everybody is here today. We live in such crazy times. I don't know about you, but I've never in my life experienced any thing like the events that we're experiencing now. Just to be clear. I mean, I'm 65 years old, and so I'm not, ancient, but believe me, I've never seen anything like this with a virus that's ravaging through Arizona, in which people are, more people are getting sick every day. Most people are getting well after they get sick, but I guess I probably watch too much news because I hear about all these kind of things that happen to people after, and I think, oh, great, some people get the virus and they don't even know it, and then they're fine. And other people get this virus, COVID-19, and they get sick. It's miserable for long periods of time, and then they suffer for periods of time afterwards. And I don't want to get that virus if I can avoid it. So I'm doing what I think is right. Okay, I tend to believe when the CDC says do these things, I try to do them. Viruses are not living things. They and I will tell you why viruses are not living things. I mean, this is biology class, right? Viruses are not living things because they are not made of cells, and they do not have the structure that we associate with living things. Living things, and I will teach you this, have a very specific structure. Viruses have a radically different structure than that, and therefore, at least now, they aren't classified as living things. But viruses are very interested in one thing. Viruses want to do one thing, and that is copy themselves. That's the driving force that motivates viruses, is to copy themselves. They are replicators, and they want to replicate and replicate and replicate. They're driven by their genetic material, because they do have some genetic material. They're driven by their genetic material to replicate. And so they're not evil. They're just driven by a desire to replicate. And so they do whatever it takes to replicate. And I'm one of those people that when I go out, I wear a mask everywhere. There was a period of time where I wore gloves until I realized that probably was just as effective if I would wash my hands a lot, and I carried Purell with me everywhere and all that kind of stuff. I mean, I was putting Purell on gloves. But I am one of those crazy people that, when I come out of a store, I put Purell on my hands, and I put Purell on my steering wheel and my gear shift and whatever. I mean, if I accidentally touch my face, I rub Purell on my face. So anyway, but I'm determined not to get the virus for a number of reasons. One reason is that I take care of my 87-year-old mother who has respiratory issues already. And I don't want to transfer the virus to her. I don't want to transfer the virus to my cats. I don't want to transfer the virus to my wife. I don't want to transfer the virus to my dog, if I can do any of that. So I'm trying to do the best I can, just like you are. Anyway, if you go out to get supplies, by my behest, please be very careful when you're out there. Limit how much time you're out there and be as safe as you possibly can, because I know I've asked for people to go out and get certain supplies. So I actually went to the Dollar Tree last night again because I wanted to find a different kind of ruler, one that maybe you could actually sort of see through. And even better than that, not only see through it, but flip it over this way so that if it's appearing backwards on the screen, it will still be readable. Anyway, I was kind of astonished how empty the shelves were in the Dollar Tree. And anyway, sorry. I just feel like it's biology class, so I have to talk about some biology. And so, anyway, if you do go out in order to gather equipment for this class, and I'm trying to limit how much stuff that you have to get, please be really safe when you're out there. I don't want to lose any students. All right, so I'm back to here again. Whoops. I'm back to the agenda. So thanks again. Welcome, everybody. I'm actually on the yesterday's agenda. All right, so if you haven't sent the student information sheet to me, please do it as quickly as possible. I mean, it's something I kind of need to get my mind wrapped around the class and organized around the class and all that. The student information sheet is available on D2L, and it's available on my PIMA in 2 different places. So it's available in D2L. It's available on my PIMA. You can download it from either of those spaces, fill it in, take a picture of it with your phone, and send it to me at smacky@pima.edu. Remember, smacky@pima.edu is my email, and you want to communicate with me by email, of course. Anyway, if anybody is brand new today and you were not here yesterday, this has been posted in a couple of different places, and it's really just an opportunity for me to get to know you. And that's kind of challenging under the present circumstances. I mean, in a regular class, I would at least be able to look at people in the face and start to memorize what people look like and what they sound like and all that. And it's a little bit more challenging under these conditions. And as I admitted yesterday, I'm not entirely new to virtual classwork. I've finished the last semester in virtual classwork, but I am hardly an expert on it, and that's pretty obvious, I think. All right, so student information sheet. Now, syllabus and schedule. Well, you know what? I didn't download that. I didn't open that document, so let me open that document right here. And this is posted on my PIMA and D2L too, of course. I mean, it is listed as syllabus and schedule. It's listed as syllabus and schedule, so you should be able to access it pretty easily. And I even ask you to initial a line on the student information sheet that just acknowledges that you've looked at the syllabus and the schedule. Now, I said this yesterday. I said, look, there will be a couple of questions about the syllabus on the first quiz, and the first quiz is Tuesday. And that quiz is I'm going to make that available before class on Tuesday, and it will not be due back until noon on Thursday. And it is not going to be in a D2L format right now. It's going to be in a format where you'll need to complete it and then attach it to an email, either by taking a picture of it or just downloading it and filling it in and attaching it, or something like that. But I'm hoping people will be able to do that. If you have problems, then you should let me know, and I'll use my limited knowledge of how to do this stuff to help you understand it. But we probably spent, I don't know, 45 minutes or an hour going through this yesterday, and I don't want to do that again. Oh, I know what I wanted to say. I wanted to say that the questions that are going to be on the quiz on Tuesday, pretty straightforward stuff, are going to be from the front page. That's page 1 of the syllabus. That's not a front page, but it's page 1. Or they're going to be from the top of page 3, where all this course grade determination stuff happens, right? That's where I'm going to pull those questions from. I'm not going to pull the questions from this long list of performance objectives. Don't worry about it, okay? Don't worry about me asking a question from that, okay? So there is important information on this first page. One of the most important pieces of information, I guess, is this one. Here's my email, smacky@pima.edu. I think it's easy to remember. And so if you would If you have any questions or concerns, or if you want to send me assignments, one way to do it is to send me that stuff at smacky@pima.edu. Okay. Again, my name is Steve Mackey, and I've been teaching Bio156 for a long time. Not so much in a virtual format, but so it's brand new to me, and I'm going to do the best I can. I mean, my ultimate goal is to provide you with the material that you need and some of the experiences that you need to be successful in your next classes, which for most people in this class is 201, is Bio 201. I said this yesterday. You can enroll in Bio 201 now if you are registered in Bio156. The computer will recognize that you're enrolled in one of my Bio156 classes, and it will let you enroll in Bio 201 for the fall. Now, I'm going to tell you, they were concerned about enrollment in the fall. So they deliberately actually kind of tuned the number of classes down a little bit. 15% is what I think they said. So if you want to get in a 201 class in the fall, especially if you want to get in one of those classes that's taught by some of the superstar anatomy teachers, you want to do it as soon as possible because there's probably less enrollment than normal. Okay. Now, if enough people try and enroll, they may open some new classes. But my advice would be, if you are planning to go into 201 in the fall, you can register now because you're registered in Bio156, and you should go ahead and do that. Okay. That registration is open. Other things that are on here that are just worth mentioning really quickly is the idea that I'm not requiring the textbook, right? I mean, again, my philosophy about textbooks is that if you're going to charge somebody $148 to buy a textbook, you better use the heck out of it. And honestly, in my opinion, under these circumstances, it's not as useful as it could be. Certainly, it's not worth $148. I'm going to provide you with plenty of things to look at and read. Okay. The same thing was with the lab manual. I have to provide you with the labs because the labs have to be designed for at-home use. That does create some limitations, but the bottom line is that that lab manual is designed for in-class use. So we're in the process right now of completely modifying that lab manual, and I will make the labs available to you. So you don't have to worry about buying anything except that list that I created of stuff that I was asking you to get. Okay, so just for the heck of it, let's look at that list again for a minute. Am I bouncing all over the place? Yes, I absolutely am. I recognize that. Somewhere here, I'm going to go drop this down. I'm going to drop this down. I'm going to go over to this. And here's what I'm going to do. Sorry, just decided this would be a good idea to post this information here so I can get to it quickly. Uh-oh, this is going to be crazy. Now, let me put it down here. Sorry. One of those things I should have done already, huh? Hey. All right, so here we go. Here's the list of things that I asked you if you would get for the class as quickly as you can. I'm going to just call this for now the list. Now, honestly, this isn't everything that I'm going to need you to get, but it's a darn good start, okay? All right. Sorry about that. There we go. The lid list, I asked you if you could get a ruler that has metric units on it. Of course, most rulers do. A measuring cup that's labeled in metric units. Most kitchen cup measurers have cups on one side, cups and ounces on one side. That's the evil English system. And metric milliliters on the other side. A 1 liter bottle, so that you can sort of picture it physically, the 3 dimensions of a 1 liter bottle. Some Alka-Seltzer tablets. You need 3 tablets. Ooh, and somebody yesterday said that you could buy individual Alka-Seltzer tablets at Whole Foods for 50 cents, I think. 50 cents a packet.
Question
I
on
hate
the
to ask
cup?
you. Yes.
What's the minimum amount that we should have on that? Because I have one that starts at 100 milliliters, but that seems like a bit.
It starts at 100. No, that's because 100 milliliters is like close to 3 ounces. So no, that's fine. I want you to be able to picture milliliters and perhaps even use that cup to measure out the volume of water in an experiment that we will do. So that should be fine.
Okay, cool. Thanks.
And then I asked to buy some soft candies, like gummy bears. We need to get some gummy bears because the bottom line is with gummy bears is that we're going to use gummy bears for some experiments later. And whoops, what the heck? All right, anyway. Gummy bears are something you want to get a bag of. Hopefully you can get one for, $1. And then gum drops and, those little marshmallows, either white or multicolored would be great. What happened there? And then I said, please try and avoid eating these things. I mean, they don't call to me. I've got them sitting on my desk and they're not calling out to me to eat them, but maybe they will when I start, using them to build molecules with marshmallows, gummy bears, gum drops. I know it sounds crazy, but it's I don't want to ask people to buy a molecular model kit that's expensive that we will only use for a short period of time. And then we're going to need to bond those soft candies together with covalent bonds, which are going to be represented by toothpicks. Okay, so any kind will do. I think we'll need at least 50. I mean, you can get one little container or box, you're probably going to be set. And okay, so we'll think about that later, but that was nice to throw in there. And I'm going to go back down here to where I was. I don't know if things are kind of hidden here. There it is. Okay, so again, here's the no, I shouldn't have done that. What was I thinking? I know what I did over here. All right, so back to the syllabus before I drive myself crazy here. Back to the syllabus. Are there any questions on the syllabus and schedule? That's what I really wanted to ask. I mean, remember that when it comes to points in here, there's a midterm exam worth 100 points. That's I tentatively scheduled that for the 15th of July. So that's a little less than 2 weeks from today, but we're going to be covering a lot of material between now and then. I'm working on trying to figure out how to format that exam and set it up on D2L right now. There's an end term exam, which I have right now scheduled for the 29th of July. Okay. Then, like I said the other day, there's an optional final exam. Optional means that many people won't take it. If you're happy with your grade already, then you probably aren't going to want to take this comprehensive and cumulative final exam. The only reason somebody would take this cumulative and comprehensive final exam is so they can replace an earlier exam score that they are unhappy with. So I think I said yesterday, supposing you take the midterm exam and you get 61 points out of 100, and so you're not happy with that, well, you could take the final exam, get 91 points on it, and I would replace the 61 with 91. That's how the optional comprehensive final exam works. And then I'm going to give 6 official quizzes on the record, but I will actually give at least 7 quizzes actually. And if I can give, I'll certainly give 1 bonus quiz at least. If I could figure out how to give an extra bonus quiz, I will. And you can take every point you earn on all those quizzes. So there's at least 1 quiz that's totally bonus. If you don't do well on one of the quizzes, then you know you have the opportunity to get some extra bonus points on quizzes to plump up your, okay? So we're going to work through that in terms of the strategy for quizzes and those kinds of things. I'm not going to worry a lot about that today. And then as far as lab activities, we've got about 140 lab activity points, and total points are 400 points, okay? That was review. We did that yesterday. And I will post grades and all that kind of stuff on D2L, of course, so you'll have the opportunity to, access your grades pretty easily. It is true that I'm going to set a time limit on these quizzes, but this time limit is, I have to say, when I say time limit, I mean something like 24 to 48 hours. So nobody is going to be able to say, well, I'm not going to have enough time to complete the quiz. It's not going to be one of those quizzes that's on D2L, let's say, that you start it and you have 20 minutes to complete it. No, you'll have plenty of time to complete it and get it back to me, okay? And I know it's crazy, but at least for now, the quizzes are open note, open book quiz. You can consult anything you want to answer the quiz questions. You shouldn't have to go very far. You shouldn't have to go further than my PowerPoints and things like that, or the labs or other things that have happened in class. But you could, if you wanted to. The only thing I don't want people doing, and I know we're under an honor system here, is I don't want people working together on the quiz. I want you personally to work on the quiz, okay? So can I ask, are there any questions on the syllabus at all?
I don't have any.
Be happy to answer any questions that we have. And of course, if you have a question, you don't want to ask it right now out loud in class, then please email.
I actually have a question.
Sure, go ahead.
Well, I started looking at the lab yesterday, and there's one part where it's measuring mass. Do we need a scale or like?
No. It's an interactive online scale.
Oh, okay.
Yeah, that would be crazy. I forgot to put that on the list. You need to buy a triple beam balance. No, I'm only kidding. Of course you don't.
All right, perfect. Thank you.
You're welcome. Uh-oh. Sorry. Look, as I said, any other questions about the syllabus? If you don't want to ask them out loud here in class, then please email me questions. All right. So I gotta go back to me wherever I am here. I don't even know where I am here. There I am. Because look who's behind me. It's the 10-kilo cat. This is a very famous cat in Bio156. His name is Mouser. He's actually on another computer, which he's not supposed to be on, Mouser. Mouser.
I have a question real quick.
Yes. Go ahead.
So, I know you were saying that for the quizzes, it's like you got like a 24 to 48 hour time period to take that.
Yes, absolutely.
How does that work for like the midterm and the exams?
Well, you know what? I'm going to tell you. I'm trying to set it up for the midterm and the exams, so it's a little different than that. Okay, but you will have. I'm not going to time those exams either. You're going to have an absurd amount of time to work on that. Okay. And when I say absurd, I mean, you're not going to have 2 hours to work on them. You're going to have 24 hours to work on them.
Okay.
No matter what. So anyway, I've got a picture in one of my PowerPoints of Mouser later, because Mouser was very famous for a long time. His name, because he was kind of known as the 10-kilo cat. And so I've actually got a picture of him. Mouser's actually had a line cut recently. because it's summer and he's big and fluffy. But anyway, it isn't impossible. No, Mouse, I'm in class now. No. So you had Hank, Danny, you had Hank with you? Well,
Yeah.
Hank was well behaved. He sits on the bed. Mouser's a different story. He jumps on the computer and all that. He's a typical cat.
Yeah, I got him for. I got him in Wounded Warrior Battalion probably about 2 years ago.
Wow. So he's a military dog?
Yes, he's a service dog.
Wow, very nice.
Yeah.
Well, they tried doing military stuff with cats and it didn't work out well.
Yeah, I'd say so.
I mean, a dog is perfect for that, but cats not so much. Well, anyway, my cats, Mouser he just so happened that he pushed the door open and came in here into the little studio, and but he is mentioned in the PowerPoint because he's sort of famous for being the 10-kilo cat. I've been taking care of this cat family. There were 13 members of it, and there's only 2 left now, and Mouser is the oldest living cat in that cat family. He's only 15, but he's outlived all his brothers and sisters and everybody else. All right, so sorry, enough cat stuff. Where was I? I was back here, and I was right here, and just wanted to make sure that we went through the agenda. And so syllabus and schedule, again, if you have questions about it or concerns about it, please let me know. I did not do something I always think about doing. I always think about embedding something in it that says something like, Steve gets to use your car every other weekend. I would just want to throw it in there and then see if anybody would even notice it. But since syllabi are like a legal document, I'm afraid to play any games in there. Okay, next thing on the list here, and this is going to be more current for today for sure, is this thing where it says TQ, A, and O through W. Well, let me remind you what TQ stands for. It stands for thought questions. And this is a document that, again, is posted both on my PIVA and on D2L. It's my thought questions. This is something that I've been doing for years because I finally realized one day that students can't read my mind. So I decided to take questions that were in my mind about this material as we're going through it, and I decided to just put them straight on paper and make them available to you. Now, I'm going to bounce around in this list, like it's not maybe as well organized as it could be. Like the very first thought question I've asked you to look or think about is this one: what is the definition of biology? Which is something I handed to you on a silver platter yesterday in a PowerPoint that's also posted called What is Biology? I'm sure you remember it, because in it you may have discovered that even though you didn't know it, you were training to be a biologist. Remember, a nurse is a type of biologist that specializes in the maintenance of human health and the treatment of human disease. So sometimes people enroll in this class, well, we talked about this yesterday, they enroll in this class for the 50 grand a year. I want that money. They're like, Steve, show me the money. And I think, well, you know what? You don't actually get that money until you have completed all these prerequisites. That's, for most people, that includes Bio156, Bio201, Bio202, Bio205, so 4 major bio classes. And then you can apply to the nursing program, radiology program, etc. And then you get in that program, and then you do the 2 years in that program, a very good program, and then you make the 50 grand a year, right? And I hate to say it this way, if you survive all that stuff. Now, in this case, like I said, it's important for us to realize that, you know, we're training to be a biologist, and that we will learn all this basic biology because we're trained to be a biologist, and then we will specialize as a radiologist. A radiologist is a type of biologist that specializes in the imaging of human bodies for the maintenance of human health and the treatment of human disease. So we are going to learn to be biologists. So a bunch of these questions at the beginning have to do with science, which we might start today. But then starting with O, that's where there's a chunk of metric system stuff. Do you see it? Like, what is a milliliter? What is a microgram? What is a terameter? Well, those are things we need to talk about today for sure. Now, I did provide this document in a format where you could edit it, and that means that you could essentially spread these questions out and fill in the answers if it would be useful for you to do that. I think that's a useful thing to do, but I want to be clear that I'm never going to ask you to turn all these questions in, okay? Maybe I wasn't clear about that yesterday. I want to be as clear as I can. I'm never going to say to you, hey, turn in question G through P. No, I'm not going to do that. You're going to see these questions answered on PowerPoints, in the lab manual. You're going to see them appearing on quizzes and exams, okay? So don't be surprised when that first quiz comes and you see on it questions that are clearly thought questions, okay? So I'm going to reduce this, and that takes us to thought. That's what the TQ here stands, and so I don't have to write out thought questions every time. And they're A and O through W. O is, well, you know, let me just talk about O for a second here, because we can go up here and look at O, sort of. Whoops. I don't know why I enlarged that. Let's go to O, because O is an interesting question. There it is. Do you see it? O. It says, what is a milliliter? What is a microgram? What is a terameter? So this is actually me asking you, what is a milliliter? What is a microgram? What is a terameter? Now, yesterday, I told you that there were 3 basic central units, okay? There's this one, liter, that we use to measure volume. Gram, that we use to measure weight. And meter, that we use to measure length. So this word here has a central unit in it, or a basic unit, liter, gram, meter, 3 of the most important metric system units, and certainly the ones that we want to focus on, since we don't need to know about many of the others. But then notice in front of liter, it says milli, and milli is a prefix. Micro is a prefix. Tera is a prefix. Maybe you remember that tera, which might be one of the easier ones to remember, stands for trillion. A trillion meters is a terameter. A trillion grams is a teragram. A trillion liters is a teraliter. Well, a trillion seconds is a terasecond. Just like milli stands for a thousandth, 1 over 1,000. So a milliliter is 1,000th of a liter. A milligram is 1,000th of a gram, and a millimeter is 1,000th of a meter. Maybe you've heard, I'm sure you've heard, millisecond. So they do use seconds in the metric system as a basic unit. I'm not going to talk about it, but they do use seconds. And I'm sure you've heard something that was measured in milliseconds. So, so anyway, now here's the thing. I think I'll write in the chat, okay, a definition of these. Actually, you know what? Maybe I'll do it this way. And I just won't save it. Okay, here we go. I'll let you take a note on this. Okay, I don't mind boosting it up a little bit. Okay, but then I've allowed myself to edit this, so I'm going to drop this down. All right, and here I go. This isn't going to come back to you in any other way, so it's probably best to copy it down, right? Here we go. A milliliter is a unit of volume measurement metric system. Equal to 1,000 A milliliter is a unit of volume measurement in the metric system equal to 1,000th of a liter. Now, if you wrote it this way, if you defined a milliliter this way, 1 milliliter equals 0.001 liters. You know what? I would have to give you credit for that, because it essentially defines a milliliter. A milliliter is 0.001 liters. But either of these would be a halfway decent definition of a milliliter. Now, again, for some people in this class, this is like a new language. I explained, I think yesterday pretty graphically, that look, you have to know this system. I know it because I'm a biology teacher and a scientist, right? You need to know it because in your daily life as an allied health professional, which most of you are on that career path, you will use the metric system. And if you make mistakes in the metric system, you could kill your patient. And that would be bad. You don't want to come out into the waiting room and tell somebody that you accidentally killed their cat because you gave them way too much medication because you didn't understand the metric system. I mean, you don't want to be in that position, I am sure. And I mean, these days, they would go get a lawyer and sue you, and then you'd have to be paying that lawsuit back for the rest of your life. So I'm hoping you are motivated to learn the metric system, as challenging as that may be, because it's super important in the career path that most of you have chosen. The nursing program absolutely said to me, Steve, we need these people to know the metric system backwards and forwards before they even get here into the, okay. Now, could you have written this? Could you write 1 milliliter equals 1,000, oops, sorry, 1,000 of a liter? Yeah, sure. That would be fine too. Any of those would be fine. Okay. So what about microgram? A microgram is a unit of weight measurement. Gram means weight. In the metric system, equal to 1 millionth. That's what micro means. 1 millionth of a gram. A terameter is a unit of length measurement. Meter means length. Measurement in the metric system, equal to 1 trillion meters. You know, when they measure things in terameters, they start measuring how far it is from the Earth to Jupiter or something like that. These are huge units, huge units. Okay, now here's the crazy thing. This question, question O, I want you to remember this, and you're writing this down in your notes, I know, is look. There are 3 basic units times 12 prefixes equals 36 possible questions. Exclamation point. So I want you to be aware that the question O, it is actually just the tip of the iceberg. There's actually 36 possible questions embedded in this. What is a milliliter? What is a milligram? What is a what is a milliliter? What is a milligram? What is a forgot what the other one was. Crazy, huh? What is a milliliter? What is a millimeter? What is a milligram? What is a microliter? What is a microgram? What is a micrometer? See what I mean? There's 36 possible questions. Remember when I told you that that these questions would be useful for review? I did not mention to you that some of these questions actually technically have multiple parts. Okay. So while everybody's looking at these notes here, can I answer any questions about how I've defined this here? There's more than one way to define it correctly, okay? The first way I wrote a milliliter is a unit of volume measurement in a metric system equal to 1/1000th of a liter. Well, that's like the Wikipedia definition. But the bottom line is that you need to know these prefixes, of course. I'm going to shut this document down. Please ask me if I want to save it, because I don't want to save what I just did. However, I will put that same definition over in the chat line somewhere. Nobody has chatted at all. Amazing. Let's see what this looks like. Okay, good. So it's in the chat line now. You can also, if you somehow didn't manage to get it down when I was talking about it a second ago, it is in the chat thread now. Okay. And that, I think that's important. I mean, there's a very good chance I'm going to put a question like that on the upcoming quiz. Okay. So you'll be able to consult it. Nope. Here we go. Back to here. Back to daily agenda. I think we're almost done with this. We are going to right to the metric system PowerPoint, and we are going to talk about this metric measuring at home lab. We're still going to take a break here today at some point in time. I try to take a break maybe every hour and 15 minutes or so. So we started at 1:15. So I feel like we should take another break around. We should take a break around 2:30, and then we won't take another break until I stop talking at 3:45. Okay, and then people will start working on the lab. And if you are just sick and tired of biology then, and you want to work on the lab over the weekend, fine. But what I'm really absolutely planning is to come back on Monday and answer questions people have about the lab, though I'm sure there will be people who will complete it, and they will take pictures, and they will, they'll figure out how to submit it to me and send it to me by email or submit it on D2L. Okay. So we'll figure that out. Where am I now? Please don't worry about interrupting me. Please, if you have a question of any kind and you want to ask it, just either put it on the chat stream, and I'll try and keep an eye on the chat stream, or put it on the chat stream, or just activate your mic and ask. It's not going to insult me in any way if you do that. In fact, I would appreciate it, because in class, people can raise their hand, but there's no way to raise your hand in here that I can tell. Okay, so here I am back at a PowerPoint that we started working on yesterday, and I'd like to get as far as I can in it today. And I modified this PowerPoint from yesterday, and I'm not going to work our way through all of it. Most of this we've already, or a chunk of this we've already done. Up here, this slide might be important because in some respects, this is an answer to the question, why is the metric system better than the English system? Well, one thing I said yesterday was that the English system, the imperial system, the system we're used to using that has things like inches and pounds and miles, that system was cobbled together over hundreds of years, and some of the units nobody really understands exactly where they came from, and they're not very consistent. Here's what I mean. There's an ounce that refers to volume, and there's an ounce that refers to weight, and they're spelled the same, and they look the same, and they are spoken the same. But sometimes you don't know if you're talking about an ounce in weight or an ounce in volume. Are we talking about the ounce in which there's 16 ounces in a pound? Or are we talking about an ounce in which there's 8 ounces in a cup? Those are not the same thing, but they sound the same, they're named the same, and they are just an example of why the English system, the system we've mostly learned since we were a kid, is, it's inconsistent and kind of silly sometimes. I wish we could just sort of forget it exists and go straight to the metric system. Anyway, they sat down in 1790, had a big conference, made decisions about the metric system right then and there. They decided it was going to be based on powers of 10, which makes the mathematics of it way easier than anything you'd have to do in the English system. They decided there would be these standard central units. Now, look, this is a subset. There's other units like candle power and seconds and things like that. But these are the big ones, the ones that we need to know about. Length is a meter. Volume is the liter. Weight or mass is the gram. And then there's a set of standard prefixes like milli, giga, kilo, and many more, which we've already talked about. I showed you the list like this the other day, yesterday, and I went straight to here and said, look, here's where 1 meter, 1 liter, 1 gram is. If you go in this direction, you're multiplying, 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 multiplying. But look, the biggest one that we need to know about is T for tera. And so these other ones, peta, exa, zeta, yada, oh my gosh, I said this yesterday, still amazes me. A yotagram, which is 10 to the 24th grams, right? I mean, it's a septillion grams. That's the weight of the water in the Pacific Ocean. It's 1 yotagram. Now, if we go in this direction, we're getting smaller units like deci, abbreviated as lowercase d, is 1/10. 1/10 of a meter, decimeter. 1/10 of a liter, deciliter. 1/10 of a gram, decigram. And we go up this, till we get all the way to yocto. And I said this yesterday. I recently read that the weight of a proton in the nucleus of an atom is 1.7 yoctograms. But I don't want you to know that much. We're going to stop here at pico, which you notice is 1 trillionth. So we're going from 1 trillionth to 1 trillion. You don't need to know yocto, zepto, atto, femto, the Marx Brothers, right? You just need to know from pico, which is 1 trillionth, down to tera, which is 1 trillion. Okay. So this is just designed to remind it here. It's designed to remind me that you need to know what this means. Like billion, what is the name metric prefix for billion? It's giga. And it is times 1 billion. Now, I went through this yesterday, all these metric prefixes, and I said, you know what? You need to memorize these metric prefixes, and you need to know how they are abbreviated, right? You need to know how they're abbreviated. So capital T stands for tera, capital G stands for giga, capital M stands for mega. Okay, the capitalization of these is really important. Then notice that kilo, hecto, deca are not capitalized. Those are all multiplications of the basic units. Then we have the divisions of the
Really
basic.
fast.
Yes, go ahead.
On the previous slide, it was saying that DA was 10 to 0. It would.
Oh, you are right. It's
wrong.
10. Thank you. Thank you very much. That is a mistake there. And, well, I'm going to make a point of correcting this. Fortunately, I repeat this stuff multiple times, but you are right. That is wrong. That's 10 to the first power, not 10 to the 0 power. Thank you so much for catching that.
Mm-hmm.
Thank you. And, I mean, that would really bum me out. It really does bum me out, but it would bum me out even more if I didn't have other ways for us to look at it. Now, this is making me crazy, this particular slide. Okay, I'm going to go down to it and explain it. And I'll tell you why it's making me crazy. There is a link embedded right here. There's a link that is embedded here that I can barely see. Can you see it?
Barely.
There. And I have no idea why. Maybe somebody out there in the listening audience can tell me this. I made this dark black and then saved it, and it refuses to be that color. I mean, at least I can sort of see it. I feel like when I first came on this slide.
Actually, I'm looking at the PowerPoint on my screen, and it actually is black because I think you reposted it and you're looking at your old upload of that.
Maybe.
Because I have it on my screen where it has the link in black.
It does. Okay. Yeah. Well, that's great. This and I mean, the thing that's weird about it, of course, is that even if it's hard to see, if you start scrolling around, you'll see where it will tell you that, look, that there is in fact a link there. And so this version that I'm using here, I thought was the most up-to-date version. But anyway, there's a link here, and this link is about what we call metric conversion, which is something I'd like to talk about. Okay, I'd like to talk about converting between one metric unit and another. Now, let's go up here for a minute. Take a look at this scale that I put up here on the top, okay? This scale has a mistake too. You know what? Maybe you're right. I need to correct this mistake. Does everybody see this mistake right here?
Yeah.
This shouldn't be a capital
right?
D. This should be a lowercase d, a, m. Now let's see. Yeah, it's wrong there too. That's making me. Now see, it's right there. Darn it. Okay, so make a note, please. Go back to this. Where am I? And I'm going to correct this, and I'm going to repost this for sure, because how these things snuck in, I don't know. I don't know how they snuck in because I'm not really sure. But anyway, this should not be a capital D. There is no capital D in metric prefixes. This should be, it should be D-A-M. Okay, so let me escape for a minute. Because it's going to make me crazy seeing this. It's just going to make me insane. I apologize. It's just like I said, it's going to make me crazy. That's what it should look like, okay? There we go. Now we have the entire scale, but where also was it wrong here? Correct that too. Ooh, that's making me crazy, but that's just me. You know, I'm like super picky about the metric system, and as a result, it makes me insane when things are not done quite right like that. I think it's right in the other documents that I put here. Yeah, it is. Okay, so I'm going to go back to here. I apologize for that. We're going to save that correction, and I'm going to go back to the slideshow. And there we go. And then, as I said, hidden down in here, oh, it's hidden, I can barely see it, is this link to a YouTube video that explains how to do metric conversions. Okay, so this is a video that I'd like you to check out, okay? But let me say something about it. You can start looking at it at minute 4:45. The beginning of it isn't bad. It's just, I don't want to waste your time. The beginning of it, the guy's kind of rambling on, just like me, about the metric system, and that's fine. But at 4 minutes and 45 seconds, he starts talking about how to do a metric conversion. And metric conversions are questions that sound something like this. How many decameters in 100 meters? How many millimeters in 25 decimeters? How many megameters in 15 micrometers? That's what metric conversions are. And metric conversions are something that you need to know how to do, okay? So let me just explain the scale that's right here. And this scale is something you can always consult when you do metric conversions. It is totally fair, not a problem. When you want to do metric conversions, you can consult this scale. But in order to really use it, you need to understand it. So let me explain it, all right? Right here in the middle, in bold and large, there's a big old M, and that big old M stands for meter. Meters were the first unit they really decided on officially at this big conference in Paris in 1790, the meter. And they defined the meter as, at that time, they defined it as 1/10,000,000th of the Earth's quadrant passing through Paris. So essentially, it was 1/4 of the Earth's circumference from the poles around the Earth back to the poles, and they were wrong about it. It wasn't exactly 1/10,000,000th. They discovered later, but they still kept that same meter, and they use that same meter to this day. So meter is one of the central units, right? There's 3 central units: meter, liter, gram. Meter, liter, gram. Now, can I point something out that's super important? You notice that meter is in lowercase. Meters are written in lowercase always. Why? Because we don't want to confuse this with this. Capital M, when we talk about the metric system, it means mega. It's a prefix that means mega, which means 1,000,000 times 1,000,000. So if you wrote capital M, lowercase m, that's mega meter. So the meter is abbreviated in lowercase. Grams are abbreviated in lowercase always. Why? Well, think about it. If you used a capital G, then you would be using the capital G for giga, which means times 1,000,000,000. Now, here's the one exception to that. Liters are always abbreviated with capital L. Now, that's great, because if you take a look at any of these prefixes here, you don't see any L's, so great. But the thing is, if you were to use a lowercase l here, it could be confusing. It could be confused as a 1 or something else. So we always capitalize the abbreviation for liter. Lowercase, lowercase, capitalized. Now, where I've put M here, I could have put M, which I did. I could have put L, or I could have put G, because all three of these are the central units we're going to think about. Now, when you move to the left over here, notice you are multiplying by 10, multiplying by another 10, 10 times more, 10 times more, 10 times more, 10 times more, times 10, times 10, times 10, times 10, times 10, times 10. So these asterisks here, they represent powers of 10. A decameter is 10 meters. A hectometer is 100 meters. A kilometer is 1,000 meters. This asterisk is 10,000 meters. This asterisk is 100,000 meters. This capital M is 1,000,000 meters. This is 10 million, 100 million, a billion, 10 billion, 100 billion, a trillion. So these little asterisks represent decimal points, decimal holding places. 10 times 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 10, right? For the multiplication of 10, it's called deca. For a multiplication of 100, it's called hecto. For multiplication of 1,000, it's kilo. But there is no name. There's no prefix for 10,000. There's no prefix for 100,000. There is a prefix for 1,000,000, but there's no prefix for 10 million, 100 million. There is a prefix for 1,000,000,000. There's no prefix for 10 billion. There's no prefix for 100 billion, but there is a prefix for a trillion. All right, is that confusing enough? This scale, however, will help you keep track of the decimal point. When you do metric conversions, because it's powers of 10, the math, well, it isn't even math. It's moving a decimal place to the left or to the right. Now, believe me, I'm going to try my best to show you what this looks like. And that's why I said originally I tried to make a movie this morning and I just couldn't do it. So that's why I went through YouTube and I found this guy's presentation, which I thought was pretty good. Again, though, you can start at 4 minutes and 45 seconds for the conversion part. And because that's what he focuses in on, the conversions. And he does a pretty good job of explaining how to do those conversions. Okay? All right. So what does a metric conversion look like? If I just touch my mouse the tiniest bit, if I breathe on it, it goes backwards in the slides. So let's take a look at this question. How many meters in 12 kilometers? Well, down here, there's the good old scale, right? Which I've said to you, you can go, here's times 1 trillion, and here's times 1 trillionth. 1 billionth, 1 millionth, 1,000th, 100th, 1/10th, 1 liter, 1 meter, 1 gram, times 10, times 100, times 1,000, times 1,000,000, times 1 billion, times 1 trillion. Plus these asterisks, of course, are part of the scale that you have to be able to consult. In my classroom, I have this scale above the door, above the board. It sits there, you know, all year long, and people consult it all the time. But let's take a look at this first question. How many meters in 12 kilometers? Okay, so does this look right up here? Yes, it does. So how do you calculate how many meters there are in 12 kilometers? Well, I got to tell you that this takes me all the way back to 6th grade, because my 6th grade science teacher showed me how to do this. And what he said was, you look at the question, I want to know how many meters, so I don't know this number. I do know that I have 12 kilometers. So I'm going to start with the number I know. 12.0 kilometers. Oh yeah, it's true. I put the decimal place right here where it belongs. Remember, if you don't know where the decimal, if you don't see a decimal place indicated, then the decimal place is always to the right of the last written number or zero. It's always to the right. So even though we don't see the decimal here, it's actually there. It's right there. There's where the decimal point is. We're going to start with what we know, 12.0 kilometers. Okay? Then we're going to go from 12.0, but I'm asking you to convert here from kilometers, 12, to meters. So how are we going to do that? Well, let's locate kilometers on this scale. There it is right there, right? There's kilometers. And what we want to do is convert it to meters. So what we're going to have to do is hop the decimal place 1, 2, 3 spaces to the right. We need to move the decimal place 3 spaces. Why 3 spaces? Well, here I'm going from kilometers that I know, 1, 2, 3, to meters that I do not know. And so can everybody see how I basically hop the decimal point from here, 1, 2, 3 spaces to the right? So we need to move the decimal place 3 spaces to the right. Okay, that's what's great about this scale. You'll be able to go, okay, I want to convert from millimeters to kilometers. I know how many millimeters I have. I'm going to have to hop the decimal place 1, 2, 3, 4, 5, 6 spaces. But am I going to go to the left or right? I'm going from here to here. I'm going to move it to the left. So in this case, I have to move the decimal place 3 spaces to the right. Here it is. All right. So I start with it here, and then I move it 1 decimal place over, another decimal place over, another decimal place over, and there's the answer. 12 kilometers equals 12,000 meters. So honestly, what I was sort of hoping to do with this slide was something like this. All right, let me just escape from this for a minute, and let's see if I can do it. In order to do it, I'm going to have to stop presenting, I think. Okay, so I'm stopping presenting now. I'm still recording. Here's the question. I hope you could read it. The question is, how many milligrams in 27.2 kilograms? Excellent. Can everybody see? Can everybody see this? Is it right? It's not backwards, right?
Right.
Yes, excellent. Okay, so I'm going to do this. I'm going to pretend my 6th grade science teacher, right? He said, start with what you know. 27.2 kilograms. 27.2 kilograms. Okay? Now, to go from milligrams to kilograms, I need to consult the scale. Now, let me just see. Okay, here's a scale right here. This is some metric conversion practice, but do you see the scale down? Oh, no, I'm not presenting. You can't see it. Oh. All right. Well, we're going to have to use the scale. And look, here's the central unit, gram. Here's decigram, centigram, milligram. Okay, and then on this side, there's decagram, hectogram, kilogram. There's the scale. hopefully sort of readable. Okay, now we're converting from milligrams to kilograms. So that means we're going from milligrams that we know all the way over to kilograms. So we know milligrams, 27.2. We are going to have to hop the decimal place 1, 2, 3, 4, 5, 6 spaces. Now, are we going to move it to the left or to the right? Well, just follow the bouncing ball, right? I started here and I went 1, 2, 3, 4, 5, 6 spaces to the left. Okay, so I should have written this better. Should have written it over here. 27.2. Here's the decimal place. 1, 2, 3, 4, 5, 6. I forgot. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Well, now I have to put the decimal place there. And honestly, I got to put a 0 in front of it. Have to. You can't have a decimal place just hanging out there in the middle of nowhere. You have to put the decimal place there. Now, what about this? Space, 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 space. Well, those are powers of 10. When you would do powers of 10 and you have spaces like this, you fill in a 0. Okay? So there's the answer. How many milligrams in 27.2? People, why didn't somebody point this out? I screwed this up completely. Back to square one. All right, I'm going to put it up here again. Grams, decigrams, centigrams, milligrams, and on this side, decagrams, hectograms, kilograms. Because the question was, how many milligrams in 27.2 kilograms? You know, maybe it'd be good time to switch to a different biology class where I don't screw it up like this, okay? But you know why I did that? It's because everything is a mirror image. It's the bizarro universe here. How many milligrams in 27.2 kilograms?
Hey, excuse me.
Yes, go ahead.
Hey, so just so that way I'm tracking and I'm not getting even more confused. You just
believe
went,
me,
you
I'm
went backwards.
helping you get confused.
Right.
I'm sorry.
Essentially, you just went backwards, right? You did the problem backwards.
Oh, I did it backwards, absolutely.
Okay. I was just making sure I understand what's going on.
You know, I did that on purpose to see if anybody was paying attention.
All right. Well, you got me. All right.
I can always do that. Like, that's one of the great things of me. I'm never going to actually kill a cat by making this mistake. Unless I squash, there's a cat underneath me now. But anyway, how many milligrams in 27.2 kilograms? See, there was a reason I wrote the 27.2 over here. All right. Remember what my 6th grade science teacher said? He said, start with what you know. 27.2 kilograms. That's where we're starting. Okay, just forget everything I said on the other side of this. Okay. I'm surprised this even works. But, okay, so we're over here with kilograms. We're starting with what we know. I mean, we don't know how many milligrams we have. We want to know. For some reason, we want to know. Okay? So, here's the bottom line. I drew a little bit of the scale up here. We start with what we know, kilo, and we have to go to milli, right? Now, just for the record, think about this for a second. What's bigger, a kilogram or a milligram?
Kilogram.
A kilogram is big. I mean, a kilogram, I hate to say this, but because it sounds like English, a kilogram is 2.2 pounds, right? It's a halfway decent size thing. A milligram is a tiny metric unit, really. It's a tiny fraction of a gram. Okay, but don't forget, don't get caught up in fractions, because then that people think, oh, math, and then they start to phase out. No, this isn't math. It's just following the bouncing decimal point. Okay, we're going to start with kilograms and we want to convert to milligrams. We know the number for kilograms. So what are we going to do? We're going to have to hop the decimal place 1, 2, 3, 4, 5, 6 spaces to the right. Right? 6 spaces to the right. 1, 2, 3, 4, 5, 6 spaces to the right. So here's the decimal place right here. 1, 2, 3, 4, 5, 6. I'm going to put the decimal place there. I don't need to, but I'm going to put it there so I don't get lost, which is easy for me. So now it's not here anymore. What about these spaces here?
They're all zeros.
Those are powers of 10, right? And when you indicate a power of 10, like if you said 10 times 5, all you would do is add a 0 after the 5 and you'd have the answer. 10 times 50, add another 0. So you're going to put zeros in those spaces. And so here's the answer in the end. 272,000,000, which means there's 27,200,000 milligrams in 27.2 kilograms. I think I did it right that time.
Yeah.
I didn't, then I'm going to have to resign, right? They're going to replace me with one of those Android robots. But you see what I did is I started with what I knew and I moved to what I don't know. Now, here's the thing. We'll try one that's a little bit more complex than this. But in certain sense, this makes a little bit of sense. Like, okay, wow. I've got this big giant thing and I want to know how many little things there are in it. This is kind of like a question like, how many inches are there in 27.2 miles? Think about how hard that would be to calculate. It'd be 27.2 times 5,280 times 12. Can anybody do that in their head? Not me. I need a calculator for that. But can you do this metric conversion? How many of these little tiny things are there in this? Well, you don't really do it in your head, but you use this scale, and it's not really math. It's more like jumping around, moving a decimal point around. That's what it is, okay? So, look, can we take a quick break? I just need to get up and stretch. I've got some lower back issues, and it would just be good for me to take a 10-minute break, and then we'll come back, and we'll make some more progress on this, okay?
Sounds good.
All right, 10-minute break. I mean, believe me, I'll be back here in 9 minutes, but if I don't go and stretch my back a little bit, I'm going to be just doomed. I'm still recording, even though I'm not presenting, but I think from now on I am going to be presenting. So let me get back to that screen. Okay. All right. We're on an official 10-minute break. Run to the restroom now. Get some more caffeine, or at least, do some jumping jacks and stretch. All right, so I'm back. It's been 10 minutes, and again, today's going to be an unusual day. I don't plan on shortening any other classes. I hate to shorten this class, but I'm just don't want to try and reschedule this medical appointment. It took me months to get it, so I apologize. But you will have work to do when we're done. Look, here's a document that you know what? Before I go there, I better look at the chat line. Oh, there we go. So as far as today's lecture goes, Elizabeth, I mean, it's recording. I will, as soon as we're done, I will download it and I will post it on YouTube. All right, so you can take a look at it again. This metric conversion stuff, believe me, if it is brand new to you, then you are not alone, because there's plenty of people who this is brand new to. Here's a document that I provided for you called metric prefixes, and it's just another way of looking at that same stuff, right? The central units, meters, liters, grams, and these others, another way for you to study that. This is available both in our MyPima drive, and it's available on D2L2 for you to look at if you'd like. Okay. All right, so let's just go back here to wherever we were a minute ago. This particular example was one that this wasn't in the PowerPoint yesterday. I just, I was really concerned about me being unable to show you how to do these conversions. So I started to do this kind of thing where you could review where, okay, we start with what we know and we could do the conversion. It means moving the decimal place one way or the other. And in the end, we get the correct answer. Let's take another example. How about this one? How many hectograms in 25 milligrams? Now, think about this for a minute. I'm asking you how many of, whoops, I went back, huh? It's like I said, if I practically even breathe on my mouse, it bumps it back to the next slide. All right, so it's how many hectograms? Well, where's hecta? Oh, it's right here. Now, I know it says HM, but remember that it can be meters, liters, or grams. So this can be HM, HL, or HG. So we're starting at hectogram. We want to know how many of these things there are in 25 of these things. Now, again, just worth thinking. Milligrams are tiny. Hectograms are much bigger. I mean, a hectogram is 10, 100, 1,000, 10,000, 100,000 times bigger. I mean, this is a little bit like asking a question like this, which dumbfounds me every time. The question is, how many miles in 6.3 inches? How many miles in 6.3 inches? Now, if you can do that in your head, then you're a mathematical genius. I can't even figure out how to set that up. But the bottom line is, I'm asking you how many miles there are in 6 inches. There's people who would say to me, Steve, look, 6 inches is a little thing and a mile is a big thing. There's no inches in a mile, but the truth is there are inches in a mile. 6 inches is a fraction of a mile. And the minute you say fractions to people, they start putting their head down so that you don't call them up to the board to make them solve that fraction problem. But in the metric system, think about it. Get back up again. Think about it. We know 25 milligrams. We want to know hectograms. So we're going to have to hop the decimal place 1, 2, 3, 4, 5 spaces. In this case, to the left. So we start with the number we know, 25.0 milligrams. We're converting from milligrams to hectograms. We need to move the decimal place, of course, because that's how a system based on powers of 10 works. 1, 2, 3, 4, 5 spaces. Okay, Steve. 1, 2, 3, 4, 5 spaces. Duh. Well, need to correct that. It's not 4, it's 5, Steve. Okay, we're moving them to the left. We're going from here to here, right? We went 1, 2, 3, 4, 5. I'm going to repost this. Okay. We start with the number we know, 20.5 milligrams. To convert from milligrams to hectograms, we need to move the decimal place. 5 spaces. Here's the count. 1, 2, 3, 4, 5 spaces. In which direction? Well, we went from here to here. We're going to the left. Spaces to the left. I mean, we're looking at the scale above. Now, let's see if I got that right here. I moved it 1, 2, 3, 4. Need one more of these, don't we? Mm-hmm. We moved it from here. 1, 2, 3, 4, 5, and that means, yay! I'm really glad that I'm going to convert this. I'm gonna repost this, of course. Oh. There we go. Boy, I'll tell you. Okay. I apologize. All right, so we started with the number we knew, 25 milligrams. Convert from milligrams to hectograms. We need to move the decimal place 5 spaces to the left. We're looking at the scale above. 1, 2, 3, 4, 5. Okay. And there it is. We moved it 1, 2, 3, 4, 5 spaces. 25 milligrams equals 0.0025 hectograms. And I apologize that you're going to have to go back and look at the PowerPoint again, but I'm going to post this, repost this PowerPoint today for sure. Okay, I promise I will do that. Now I use these two examples because in one case we went to the right, and in one case we went to the left. But you know, there's one example that I would like to do, and it's going to involve, say, let's just involve this piece, okay? And I'm going to jump off of presenting because I want to show you what this is going to look like, okay? So the question that I'm going to pose here is, well, I'm going to just draw a piece of the scale here. Okay? So let's go for liters, and then we have deciliters, centiliters, milliliters, asterisk, asterisk, micro liters, asterisk, asterisk, micro to We went microliters, asterisk, asterisk. Boy, my brain. Nano. And nanoliters, okay? Liters, deciliters, centiliters, milliliters, asterisk, asterisk, microliter, asterisk, asterisk, nanoliters. There's a reason I've chosen this particular example. Of course, everything looks backwards until now. Hopefully it looks right now. Liters, deciliters, centiliters, milliliters, asterisk, asterisk, microliter, asterisk, asterisk, nanoliter. Okay, so here's the question. How many nanoliters in, oh, I don't know, 41.37 centiliters? How's that? Everybody can read this correctly, I hope, right?
Mm-hmm.
Well, I realize my writing leaves a lot to be desired, but how many nanoliters, that's an N here, nanoliters. So I'm asking, how many of these little teeny tiny things are there in these? Well, these are still pretty tiny, but they're much bigger than that. A centiliter is 10, 100,000, 10,000, 100,000, million, 10 million times bigger, even though it's on that side. So, okay, remember what my 6th grade science teacher always said. Start with what you know. That's the only thing we know. We know centiliters, okay? 41.37 centiliters. But what we want to know is nanoliters. So how are we going to calculate that out? Well, you know the basics, right? We're going to hop the decimal place. In this case, we're going to go from centi to nano, so we're going to the right. So I positioned this correctly. And we're going to have to hop the decimal place 1, 2, 3, 4, 5, 6, 7 spaces to the right. Now, why did I choose this particular example? Because I wanted you to see that these asterisks are super important. They are a decimal holding place. So when I went from centiliters to milliliters, I couldn't just go centiliter, milliliter, oh, microliter. No, because a milliliter is 1/1000th. A microliter is 1/100000th. Between 1/1000th and 1/100000th, look, we've got 1/10,000th, 100,000th, 1/100000th. Okay, so 1, 2, 3, 4, 5, 6, 7 spaces to the right. 1, 2, 3, 4, 5, 6, 7. I'm going to put the decimal place there now so I don't get lost. It's easy for me. And I'm going to look. The decimal place is no longer here. What about these empty spaces? Well, you know, empty spaces like that, they get filled with zeros because they are powers of 10. And whenever you multiply or divide by powers of 10, you change the zeros around. All right, so here's the final answer. 41,370. 0, 0, 0, 0. Did I get the number zeros? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros. 7, 3, 1, 4. Now, for what it's worth, let me just point one thing out about this that I think is interesting. We started with the number 4137. We ended with a number that still has 4137 in it. Would that be true if I was asking you how many inches there were in 10,000 feet? No.
No.
The numbers would look nothing like the original numbers. Okay, so here's the answer. 1,000 million. There are 413,700,000 nanoliters in 41.37 centiliters. I did this example as poorly as it looks across it. You know, feel like Mr. Rogers or something. As I did it because I wanted you to understand what these asterisks are about. Oh, between now and the next time we meet, I hope you will do a lot of metric conversions, because I am going to put metric conversions on quizzes and exams. You know what about something about the metric system? The metric system, it never really falls off the table, I'm sorry to say. I will always be willing and happy to ask you questions about the metric system, okay? Always. So the bottom line is that you want to start working with the metric system and doing these conversions and hopefully not screwing it up like I did. So here's one place to do metric conversions. Here is a document that I've posted called the metric conversion. Well, it's actually called the metric practice worksheet, okay? It's a metric conversion sheet. Now, take a look. I've set it up so it's pretty easy to work with. How many milliliters in 341.3 liters? Here's what we know. Here's what we don't know. Here's what we want to know. We know it. We want to know it, right? We know what we have here, 341.3 liters. We want to know how many milliliters it is, and here's where we're going to put the answer. Now,
are you trying to present? Because you're not presenting.
Oh, thank you. Thank you so much. Thank you.
Sure.
I forgot to switch from presenting to not presenting. Thank you. Thank you. Thank you. Okay. I'm an expert at this. He lied.
There we go.
Well, just a matter of, you know what? In the past, I've never jumped back and forth between presenting and non-presenting because I've never had to like write on something like that. I did all that. The last time I did this, I did that in a classroom. Do you remember what classrooms were like, where they had a big board in the front and you could write on it? Oh. I guess there must be some way to do that online, but I don't know how to do it online. So.
You might be able to find like a website or something, just like a virtual whiteboard. That you could use.
There is, and I've tried it, but here's the problem. When I write on it, it looks like my granddaughter, who's 2, scribbling on a piece of paper.
Yeah, that is the downside.
I mean, you can write, you can type, and it'll show on the whiteboard, but it's a little hard to do what I just did. And so anyway, I need to play with it more. So, Zenith, what was your question?
They want to know if.
Oh, are we going to use scientific notation? No, we're not. If you want to use scientific notation, like if you want to give me the answer in scientific notation, that would be fine if you're used to doing it. But I'm not going to teach you. I am not going to teach you scientific notation. It's not just something I want to get into right now. Okay. Thanks for asking, but that would be another possible way for me to screw up. Right? We try to limit how many ways I can screw up. That's the bottom line. Hematologists asked me to screw up as little as possible. So I'm trying. Anyway, I'm presenting now, etc., so I can go back to where it was. I wanted to show you this document. And this document is called it's actually written up here, metric practice. It's a metric practice worksheet. But here's the thing. I've provided this for you for practice. And my advice is that you work on this sheet as practice. Down here, look here's the scale with everything in it, right? From trillion to trillionth, everything in it. And you just go ahead and fill the worksheet in. And what I'm going to do is I'm going to post the key to it. And I'm going to give people a little time to work on it. Like today, when I have to end class early, I'm going to give you time to work on it. And I'm going to post the key to it. When will I post the key? You know, I think I'll post the key over the weekend, because I don't want people just going straight to the key and going, oh yeah, I would have got it right. You know, when you do this worksheet, you're either going to discover when you look at the key that you did it perfectly, or you're going to discover this, that you moved the decimal place to the left, but you were supposed to move it to the right. Or you moved it to the right and you were supposed to move it to the left. You know what I mean? That's the kind of mistake that you make on a sheet like this. And so it's kind of useful to play with it and then to get your answers written and then go and look at the answer sheet, which I'm not going to put up right away because I don't want somebody going straight to the answer sheet. I'll put it up over the weekend. And that way you'll get a couple days before you will get a chance to look at the key. And then you'll look at the key and you will know right away if you did, you will know if you did it right. Okay, so a metric practice worksheet, it is, no, that's not what I think it is. It is, hold on, escape. Here's what it looks like. It's posted on my PIMA. Okay. All right. And I will post a key in a couple days. All right. But you should work on it today, tonight. All right. And remember that there's another, if you have listened to me talk here today, I appreciate it because that, that's a challenge. But remember back here, there it is. There was this YouTube video. This guy does a pretty good job, and he's better than me. I mean, he has a better grasp of the technology, I guess. He does it pretty well. I mean, take a look. I'm not going to run this whole thing. I'm going to let you watch this later. Hey, come on.
And we aren't turning in the metric sheet, right? It's just for our practice.
You're not. I want you to, and I'm going to post the key to it.
Right, right.
There are conversions in the lab that you will turn in.
Cool. Okay.
Okay, see, take a look at what this guy's doing here.
And the prefix is something obviously comes before the word. That will be milli. So looking at a millimeter here, and if I have 1 meter, how many millimeters is that? Well, the base unit meter is found, where the base units are found, on the center of the number line. Milli, the prefix is found 1, 2, 3 places to the right. And all I'm going to do is take my number 1, and I'm going to move the decimal point 1, 2, 3 places to the right, just like I did up there. And now I'm going to fill these little hoops up with zeros. So 1 meter is the same thing as saying 1,000 millimeters. That's all.
This guy's a little less confusing than me, I think. Okay? The thing about the metric system is because it's based on powers of 10, we don't have to, the mathematics of dealing with these metric conversions is pretty straightforward. Okay? So I'm back here, and I went all the way up to here. I hope you can see this better than me, but it is there sort of hiding in the background, okay? And you don't have to watch the whole thing. If you want to watch the whole thing, go ahead and watch the whole thing, but you don't need to watch it. The beginning of it is stuff that I've already covered. So, I mean, here's just some questions, that's all. Here's some more questions, just because I want to illustrate the kind of questions that these represent. And then we've already done this, so you could go back and review it, and I corrected it, and I'm going to repost it. I'm going to repost it as soon as I end class today at 3:45. I'm going to post it right then, so people can go and get it, and I will repost it in both my PIMA and on D2L. I apologize. All right, there's the metric conversion sheet. Oh, here's just a joke, where it says, well, you can read it as well as I do. These questions in the bottom, how many inches in 72 feet? Well, that sounds like an English to metric conversion, or an English question. That's going to be complicated. How many centimeters in 72 meters? Much easier. I mean, there's 100 centimeters per meter. So how many centimeters in 72 meters? There's going to be 7,200 centimeters. I mean, you could just almost do it in your head. You just think about zeros. Okay, here's some essential metric factoids that I'd like to point out to you. And I really think these are factoids that everybody needs to memorize and think about these, okay? When they put the metric system together, believe it or not, they decided that they were going to link meters, liters, and grams. They were going to try and figure out a way to link the central units together in a coherent fashion. And so here are a couple of interesting factoids. Meters, liters, and grams are the central units. But if you take a unit that is a part of a meter, a decimeter, 1/10 of a meter. So, you know, probably about as wide as you can, you know, spread your fingers is about a decimeter. Actually, why am I even doing that? Here's a ruler in front of me, and I hope I'm presenting now. And this is a decimeter. All right, so everybody can see that the length I'm pointing at right here, this length here, is 1/10 of a meter. And so this is a decimeter. Now, if you take this decimeter and you cube it, you're really doing something that sounds like you're dealing with length units, since it says the word decimeter right in it, okay? If you take a cubic decimeter, that is the definition in terms of volume of 1 liter. 1 liter is a volume that's based on a cubic meter length measurement. 1 cubic decimeter equals 1 liter. Now, 1 liter, by definition, this is the way they set it up, it isn't a coincidence, weighs 1 kilogram if you're talking about liquid water. It's only for liquid water. So here's what this means. It means that they based the weight system in the metric system on water. Again, liquid water. And I got to say, water is not only a super important biomolecule, it's one of the most common molecules on the planet Earth. They chose a natural substance as a reference value. 1 liter weighs 1 kilogram if we're talking about liquid water. It doesn't count if it's ice. Ice weighs less than liquid water. Solid water weighs less than liquid water. You know how I know? Because ice floats on my soda. It floats to the top. Ice weighs less per unit than liquid water. So we can't, removing my mouse. You got to, so that's the bottom line. It isn't going to be solid water. It isn't going to be steam, which is the gaseous form of water. It certainly isn't going to be plasma form of water. It's going to be only liquid water. And I think technically they decided it was something like 22 degrees centigrade and sea level, but let's not worry about that. It is based on liquid water. Now, at the exact same time, these are equivalencies, right? 1 cubic centimeter, that's like a little cube that's about the size of a sugar cube, is the same exact volume as 1 milliliter. So this is sometimes written as cc for cubic centimeter, is the exact same volume as 1 milliliter. 1 cubic centimeter is 1 milliliter. And look, it weighs 1 gram if, again, we're talking about liquid water. 1 milliliter of liquid water weighs 1 gram. The definition of a gram is that a gram is the weight of 1.0 milliliters of liquid water. I think that's a nice connection. Hey, you know what that means? In my Diet Coke can, it says there's 355 milliliters of soda. And you know what? Soda is 99% water. If there's 350 milliliters of water, more or less water inside this can, what does it weigh? Well, 1 gram weighs 1 mil weighs 1 gram. So 355 mils weighs 355 grams. The bottom line is that we can see that factoid. This means that 1 liter of liquid water will weigh 1 kilogram, and 1 milliliter of liquid water will weigh exactly 1 gram by definition. Every once in a while, a student comes to me and goes, Mr. Mackey, what a coincidence. What an amazing coincidence. 1 milliliter of liquid water weighs 1 gram. And I'm like, no, it is not a coincidence. It is the way they set it up when they put together the metric system. And again, I kind of like the idea that it's a natural, kind of based naturally. It's based on water, one of the most common molecules on the planet, and a very important biomolecule. Now, if you're interested, just for what it's worth, a cubic decimeter is 1,000 centimeters, cubic centimeters. A liter is 1,000 milliliters. A kilogram is 1,000 grams. If we divide all of this by 1,000, here's where we get the 1 cubic centimeter equals 1 milliliter. These are exactly the same volume, 1 cubic centimeter and 1 milliliter. And of course, it will weigh 1 gram if it's liquid water. So please look at this. I mean, I don't care about this multiplication, this division thing, but this basic one here, these centrometric factoids are something you want to stick in your brain. All right, so now metric measurement. This PowerPoint, I think, is pretty straightforward, but let's talk. What are the kinds of things we need to measure in the metric system? We need to measure temperature. We need to measure length. We need to measure volume. We need to measure weight. So when it comes to measuring length, we use a meter stick or a meter tape. But meter tape is just, kind of like, it's just a very flexible, it's a flexible meter stick. So here's a little picture of the beginning of a meter stick. Now, it starts right here at the edge. Here's 1 centimeter, 2 centimeters, 3 centimeters, 4, 5. These units here are centimeters. Now, for what it's worth, this little piece of the meter stick goes all the way up to 10. When you look at a meter stick, you see tens. You see 10, 20, 30, 40, 50, 60. And when you look at inside this between 1 centimeter and 2 centimeters, a centimeter is about as thick as my pinky. When you get your metric ruler, measure the width of your pinky, measure the width of your palm, those kinds of things. But I want you to see here that between 1 and 2, if you can count this right, 1, 2, 3, 4, 5, 6, 7, there are 10 divisions. So these are each 1/10 of a centimeter, and 1/10 of a centimeter is a millimeter. Down here, we've got the 0 point, and notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tens. When we are dealing with the metric system, we see tens a lot, and it gives us a hint we're dealing. Now, believe it or not, I sometimes learn that college students, that they don't know how to use a ruler, believe it or not. Be sure when you use your ruler, you figure out where the 0 point is, and you start measuring there. Okay, you're in the metric system lab, you're going to get a chance to measure using, a virtual ruler and all that. Okay, so, okay. Now, when we measure volume, we use what's called a graduated cylinder. And maybe you knew this and maybe you didn't. I was told it just a year or so ago, and it amazed me. Albert Einstein invented the graduated cylinder in 1909. We never use a beaker or flask to measure liquid volumes. Oh, we might be tempted, because beakers and flasks might have markings on them, but we never use them because they are not accurate. If you read a beaker, it will say it is plus or minus 10%, plus or minus 5%. So we never use a beaker or flask. Whoops, sorry. Now, when we measure water solutions using a graduated cylinder, and you're going to get a chance to do this, you're going to notice something. Water solutions form a curved surface called the meniscus. Meniscus is Greek for crescent, and I'll show you a meniscus in a second. You also want to try and read the meniscus right at your eye level, because if you're looking above it or you're looking below it, you won't get an accurate reading. Sorry, things are messed up here. I apologize. I need to correct this too. Anyway, what did I do here? I got this when it should be there. Okay, good. Sorry. I'm going to go back here. Now, as again, you may think that you know how to use a ruler, and you probably do. But believe me, I always learn that there are people who don't know how to use rulers when I ask people to measure things with rulers. So take a look. Here's actually a ruler like the ruler you get at the Dollar Tree or whatever. Notice on this side it says inches. Well, it's nice enough to say inches, but notice that this particular inch, it's divided into 1, 2, 3, 4, 5, 6, 7, 8, 16 pieces. So there's 16. I mean, there's a number 16. Where they came up with that, I don't know. And then, of course, you see numbers, and you'll see a 10, but you won't, you will see, well, there's 16 divisions here and 16 divisions here, blah, blah, blah. But the side that says millimeters, thankfully, is referring to this metric side of the ruler. And again, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But between 0 and 1, there are 10 divisions. Each one of those is a millimeter. Between 0 and 1 is a centimeter. Between 1 and 2 is a centimeter. Between 2 and 3 is a centimeter. And when you work through this lab, you'll get a chance to play with the rules. Okay? So now we're talking about liquid volumes, graduated cylinders. We never use a beaker or a flask. Again, water is kind of an unusual molecule. When you put it in a graduated cylinder or a pipette or a micropipette, well, not a micropipette, in a pipette, it will try to climb up the side of the tube, and it makes a crescent-shaped, curved, or concave surface. You need to look and read the meniscus at the eye level. And that's what it means here, is that if here's the graduated cylinder, and then here's the meniscus right there, well, you want to look straight on at that meniscus, not from the top, not from the bottom. That's what that graphic is illustrating. Now, take a look at this graduated cylinder over here. I don't really know how big this graduated cylinder is, but I have to study it. You know, when I was a kid, I was a bio nerd from when I was 10 years old. When other kids were saving up money to buy baseball cards and comic books, I was saving up my money to buy pH paper and beakers and graduated cylinders, because I was a bio nerd and still am. So the reason I mention that is not so that you know you're a bio nerd as a teacher, but because every time I get a graduated cylinder, every time, doesn't make any difference, even though I've had 50 plus years of experience with graduated cylinders, I have to study them. So this graduated cylinder over here, I need to study it. I notice that here's 7, here's 8, here's 6, 5. I'm going to guess that these numbers represent milliliters, excuse me. So this is the 7 milliliter line. This is the 8 milliliter line. This is the 6 milliliter line. Now, let's just look up here. Between 7 and 8, there's 1, 2, 3, 4, 5 spaces. 1, 2, 3, 4, 5 spaces. So they've divided this 1 milliliter into 5 parts. So what that means is, in this case, is that each line here represents 2/10 or 1/5 of a milliliter. So this is 7.2, 7.4, 7.6, 7.8, 8.0. Now, I would not have known that if I hadn't spent a few minutes looking at this. Now, here's the meniscus. Can you see it? That it's not a nice straight line? In fact, it's sort of dipped. One end of it is close to 7, and the other end of it is just a tiny bit below 6.2468. So I'm just going to call the volume here 6.8 milliliters, right? The meniscus is down here. The meniscus rule, that's what it says at the top of this, says this, that you always read the volume at the low point on the meniscus, at the bottom of the dip. This is the crescent-shaped curved surface that water will form. Now look, there's other molecules, liquid molecules that don't form a meniscus. So why do we care? Well, because in biology, certainly in human biology, we are almost always dealing with water solutions. You know, in chemistry, it might be a completely different story. You might be measuring out things that don't form a meniscus. But if it's got water in it, it's probably got to have a meniscus. So I actually just kind of collected all of these together so we could take a look at some graduated cylinders and see how different they look. This one's kind of nice because they colored it. Look, here is the downward curving meniscus, right? It's the upward or downward curve of the surface in a liquid, but in this case, if it's a liquid water, then it is a downward curve. Now, look over here at this one. Here's, wow, 30 is way down here. I guess this is 30. We've got 1, 2, 3, 4. Oh, no, 30 must be down here a little bit. Boy, I need to get one that's a little bit easier to read. Believe me, you're going to get plenty of opportunity to do this in the lab. Okay, so what is the volume of the fluid here? Take a look. I want you to just look at it and study it for a minute. And remember what I said, I'm going to repost this corrected PowerPoint as soon as we are done with class in a few minutes, and then you will be able to go back and look at it. And we'll not have those awful errors in it. Anyway, so when I study this, again, I see, look, here's 7, here's 8. The divisions are 1, 2, 3, 4, 5 between 7 and 8. So we know that, you know, between 7 and 8, 5 divisions means that this must be 7.0, 7.2, 7.4, 7.6, 7.8, 8. So over here, if we've got 6, we've got 6, 6.2, 6.4, 6.6, 6.87. And the question is, what's the volume of the fluid here? Well, here's the meniscus. It looks to me like the meniscus is about halfway between 6.2 and 6.0. So I'm going to estimate that it's 6.1 milliliters, right? 6.1 milliliters. And again, when you do this lab, you'll get plenty of opportunity to look at those things and look at different ones. So There are some other commonly used volume measurers. It's not uncommon in chemistry classes to use a smaller unit like this, like it's called a pipette. And there can be 1 milliliter pipettes that are graduated in tenths of a milliliter. There can be a 25 milliliter pipette that's graduated in 1 mils. In this particular case, from the tip of the pipette to here is 1 mil because it's a 10 mil pipette. These things down here are micro pipettes. These are used, well, when I work in a DNA lab, this is what you use because these measure in microliters. Microliters, believe it or not. Crazy. Okay. Metric temperature measurement is how we measure, how we measure temperature in the metric system. Mostly, I know the standard is Kelvin, but Kelvin just seems like a crazy scale to me. But the word centi, of course, means 1/100th. That tells me that this should be used with the metric system. And this is either called the centigrade system, which kind of links it directly to metric stuff. Celsius was the astronomer who proposed this system. And look, you're going to use a centigrade thermometer in this lab, but I would like you to memorize and know these particular points. The centigrade or Celsius temperature scale is based on properties of water. 0 degrees centigrade is the temperature where water freezes. 100 degrees centigrade is the boiling point of water. 37 degrees centigrade is human body temperature, and 22 degrees centigrade is the approximate room temperature, and that 22 degrees centigrade is about 70 degrees Fahrenheit-ish. But I feel like knowing these little factoids is important. I mean, especially that 0 degrees centigrade is the freezing point of water. 100 degrees centigrade is the boiling point of water. One time my wife was working in a hospital and she called me on her cell phone and said, I need your advice. The nurse told me that I needed to call her if the patient had a fever, if their temperature was high. So I'm using an automatic thermometer here, but it won't convert to Fahrenheit. It's only in centigrade, and I don't know whether this person has a fever or not. And I said, well, tell me what their temperature is. And she said 38 degrees. I went, well, I think you better call the nurse because she has a fever. 37 degrees is normal human body temperature, meaning 98.6 degrees Fahrenheit. And 38 degrees is above that, so you better call the nurse. So it's good to know these in case someday you somehow end up with a thermometer that won't go back and forth from centigrade to Fahrenheit. It happens. When we measure temperature, we're going to use thermometers like this, and you're going to, let the temperature establish so it's not changing, and then you're going to go ahead and read it, and it's pretty straightforward. You get an opportunity to practice in the lab. There's 30, there's 40. It looks to me like it's divided into 10 equal units. So 30, 1, 2, 3, 4, 5. It looks to be 35 degrees centigrade. Again, good to read it at the eye level instead of looking up or down at it. Now, when you go into this lab and you start working on this lab, there's a section on measuring mass. And I'm going to just boom through this really quickly because you aren't going to actually use a digital balance. You're going to use a triple beam balance, which they still use someplace. But if you find yourself with a digital balance, then you're going to do these things. You're going to turn on the balance. Usually that's pretty easy. You're going to make sure it's set to grams, not ounces or carats or something like this. You're going to tare the balance. This word tare, it really means to set it to 0. And this may be a little bit of an archaic term, but it's an important term. Tare means to recalibrate the balance to 0. That's what it means. Now, you always tare a balance before you weigh it. I'm sorry, let me repeat that. You always tare a digital balance before you weigh anything on it, because most digital balances are really sensitive and they will come out of tear very easily. So however you tear the balance, which is usually a matter of just pushing a button in and out like this, you just push it in and out real quick, it will reset it to 0. And then, you know, if you ever do see a digital balance, I'm not asking anybody to buy one, you don't really want to put something that's really, really heavy on a balance that could squash the balance. Don't try and measure the front end of your car or something like that. Now, look, this is important, and I may end up coming back to this again. This is the only metric to English conversion you need to know, all right? I am not a big believer in metric system to English conversions. I think they are mostly useless. Oh, I've done about 10,000 of them because I had to in a class, and I always asked why. It would be better if we just completely forgot the English system entirely. It would be better. It's almost useless to have to do conversions, except for one case, and that's this case. It is the conversion between kilograms and pounds. You need to know this for drug dosing and for, you know, charting and that kind of stuff. And here's the bottom line. 1 kilogram is equal to 2.2 pounds. If you know the weight in pounds, then you calculate the weight in kilograms this way. You take the weight in pounds and divide it by 2.2. If you know the weight in kilograms, then you use this formula. The weight in pounds is equal to the weight in kilograms times 2.2. So this conversion is the only metric to English conversion I'm ever going to ask you to know about, okay? I know we're pushing up against time now, but real quickly, remember this guy? I showed him to you earlier in the day. It's a calculation about that. This is my cat Mouser, famously known as the 10-kilo cat. He had a lot more fur in this way. What is his weight in pounds? Well, in this case, kilo equals kilograms when I said 10-kilo cat. 10 kilograms times 2.2 pounds per kilogram equals 22 pounds. So when Mouser was a little younger and in better shape, he weighed only 22 pounds. He's still always been a pretty big cat. But did you see how we did this calculation? We knew he weighed 10 kilos. We multiplied it by 2.2 pounds because there's 2.2 pounds per kilogram, and we ended up with 22. Oh, notice that we multiplied this by 10. So all we did was take the decimal place and hop it over here. That's what happens when you multiply by 10. You move the decimal place 1 decimal place. Now, he's not a fat cat, really. He's just really fluffy, though. He's not so fluffy today because he had that line cut. All right, I got to escape. This is slide number 31, so I'm going to definitely start next time again on slide 29. But would you please look at the rest of this PowerPoint with just a couple more, 2 or 3 more slides? Okay, so I'm going to remember what I said. It's only going to take me 5 minutes to repost this so you have a better version of this up. I'm going to post it up very quickly. Now, when it comes to this lab is called Metric Measuring at Home. And can I say one thing about this lab? Embedded in this lab are some metric to English conversions that I don't want you to deal with. The only metric to English conversions that you need to do in here have to do with conversions between pounds and kilograms, okay? And so here's those conversions at the bottom. When they showed me this lab, I said, wait a minute. We need to include this part. This is one of the most important metric conversions that allied health people need to do. It has to do with drug dosages, etc. So I wrote this part and included some questions in it that I think are pretty straightforward. So, you know, again, with this document is a Word document. And part of me thinks that, well, no, I think the absolute thing to do is to download the document so that you can use it as a Word document and fill in the charts, put your name on it, etc. And then you can fill it in and you can send it to me by email so I can grade the parts that need to be graded. Now, again, the bottom line is that you wouldn't need to send me this entire document. You could just send me the parts of the document that have things you write in. There's lots of content here where you can actually fill things in. So you're going to take a screenshot of that and send it to me. You're going to take a phone shot of that and send it to me, any place that it needs to be filled in. Now, like I said, I am sorry I need to cut us short today. I really am bummed about that. But I'm hoping that as soon as we're done here today in 1 minute, that you will start looking at these metric conversion questions and you will start working through this metric measuring lab. Do I expect it to be done by the time we meet on Monday? No, I do not. Because I want people to start working on this lab, and then on Monday, I want people to ask me, address issues, ask me questions about it, okay, once you've had a chance to read it and actually think, uh-oh, it's going to be due. So I think I'm going to tentatively make it due Tuesday, all right? Make it due Tuesday, but I'm not, you know, if you want to finish it all up and send me it, that'd be great, but otherwise, I'm going to want to answer questions, do explanations on Monday, okay? So this is posted on my Pima. Go ahead.
Oh, nothing. I was just saying, sounds good.
Good, good, good. Sounds good. Thank you. All right, look, people, I apologize that I have to run. Next time I'm going to lecture for 6 straight hours. No, I'm only kidding. Not that I couldn't do that. I probably could, but I have to end it now. I apologize for that. I'll make it up to you somehow. And but really, you have a task to do. In a regular class, there would come a point in time where I would stop talking and I would tell people to go to work on the lab. So that's what I'm doing. I'm going to stop talking and I'm going to tell you to go to work on the lab. All right? I will see you on Monday at 1:15. Send me email questions if you have them, okay? Hey, and happy July 4th. Please don't blow yourself up with fireworks, okay? Please don't do that. All right, but have a good July 4th, a safe and healthy July 4th, and please use social distancing and masks and all that kind of stuff, especially if you're out gathering materials for this class, because I don't want to be responsible for you or being in the hospital, okay? Hang in there. Happy July 4th. See you Monday at 1:15.